Good afternoon, class. We are looking at 6.32 inverse trig functions. This is part 2. So analytic trigonometry, inverse trigonometric functions, part 2. So we want to find the exact value of expression involving the inverse sine, cosine, and tangent function. Define the inverse secant, cosecant, and cotangents. Use a calculator to evaluate them and write a trigonometric expression as an algebraic expression. Now we remember the properties of trigonometric functions involving unit circle and other circles, periodic functions, even and odd, and then some fundamental identities we have discussed. Reminding you that none of the trigonometric functions have an inverse. So we restrict them to one-to-one because none of them is one-to-one. So for example, sine is not one-to-one when we restrict it from minus power 2 to power 2 becomes a one-to-one function, and we can find its inverse. Following the fact that sine inverse of sine is x if x is between negative power 2 and power 2, and sine of sine inverse of x is x if x is between negative 1 and 1. Same thing happens with cosine. It's not a one-to-one function when we restrict it from 0 to pi. And the reason we restrict them differently because we want to cover the range, which is negative 1-to-1 for both cases. And now this becomes a one-to-one function, and we can graph its inverse. And y equals cosine inverse x. That means x equals cosine y. Now pay attention to the fact that cosine inverse of cosine of x equals x if x is between 0 and pi, cosine of cosine inverse of x is x if x is between negative 1 and 1. Same thing happens with the tangent. It is not a one-to-one function. The restriction. Now the restriction is similar to sine. Of course, the endpoints are not included because we have VAs, vertical asymptotes, and then it gives rise to its inverse and the graph of its inverse. And f inverse of f of x, tan inverse of tan x is x if x is between negative power 2 and power 2, almost like sine. The difference is the equality is working for sine, not here. Tan of tan inverse of x equals x if x is between negative and positive infinity, which is completely different than from sine, which is from negative 1 to. So that's the synopsis of what we have learned, and we're going to continue on that thoughts. So the 6.3, the inverse trigonometric functions continued. Example 1, find the exact value of an expression involving inverse sine, cosine, tangent functions. So we start with sine of tan inverse of 1/2. So please understand this represents an arc or an angle with theta, for example. So what are we looking for? We are looking for sine theta. So understand, let this one be x, y, z, theta. If theta is tan inverse of 1/2, you want sine of that. Now, we can use two methods. We remember that we can use the circles or we can use the identities, and tan theta is 1/2, and theta is between negative power 2 and power 2. Of course, that is in the right domain and range as expected. And so because this is positive, that means the first quadrant, so the first quadrant sine is also positive. Sine is also positive. So the purpose of this is to tell us which quadrant and therefore whether that trigonometric function we are dealing with is going to be positive or negative. And so with that being the case, the tan of theta is 1/2, the same as y over x. We are in the first quadrant, x and y are both positive. So you can say y is 1, x is 2. You have the graph looking like that. So if x is 2, y is 1, square that, you get 4, square that, you get 1, they add up to 5. So r is square root of 5. It's very simple, everybody. Okay, so x squared plus y squared is 5 because you square these two numbers and you get 5. And therefore, because sine theta is y over r, it's 1 over the square root of 5, and it's square root of 5 over 5. By now, everybody knows they're the same. If you have doubts, just rationalize them as follows. Multiply this one by square root of 5 over square root of 5. The second method would be identity's relationship between the tan and sine. We know that tan squared plus 1 is secant squared, and the reason we use secant squared, somehow we want to get to cosine and then sine. So tan is 1/2. Square that, and you get 1/4. So secant squared is 5/4. That means secant means square root of 5 over 2. And the cosine is the reciprocal of that. Now, we can go with sine squared plus cosine squared equals 1, or we remember tangent is sine over cosine, and I hope you see if tangent is sine over cosine, then sine is the product of these two, because you can go with the cross product. Tan of theta is 1/2. Cosine is 2 over square root of 5. These two cancels out these two. We get 1 over square root of 5. And if we rationalize it, we get square root of 5 over 5. So very straightforward, everybody. A quick recap. Sine of tan inverse of 1/2, that means tan of theta is equal to 1/2. That's the meaning of this. So tangent is given, find sine. That's the idea. So we go back to previous sections. We either use circums, y over r, or we use the identities. But again, it's important to understand this means we have this tangent value, missing is sine value. Cosine, okay, find the exact value. Cosine of sine inverse of negative 1/3. If you set this equal to theta, that means you want cosine of theta. That's what we are looking for. On the one hand. On the other hand, this means sine of theta must be negative 1/3. Now, negative. If sine is negative, and remember we're talking about the sine inverse, we know exactly which quadrant, because it is theta is between negative power 2 and power 2. Okay. Remember the choice for the sine inverse. And because sine is negative, it's actually in the fourth quadrant. Remember, sine theta can be between negative power 2 and power 2. And therefore, because this is negative, actually, this results in theta being between negative power 2 and 0. That results in the fourth quadrant. And in the fourth quadrant, cosine is positive. Okay? Cosine is positive. So let's work this out. Sine is negative 1 over 3, which makes it y over r. So y must be negative 1, r must be 3. And here's x squared plus y squared equals 9. So Square this one. Okay. Square this one. Subtract this from that and look for x. So let me show you how we got that. So remember, x squared plus y squared, x squared plus y squared equals r squared. So x squared plus 1, that equals 9. So x squared equals 8. And x is plus minus square root of 8, which is 2 square root of 2. And the reason we choose positive because of the quadrant. Because of the quadrant, everybody. So this is 1. This is 2 square root of 2. We're making it larger. And this is 3. Cosine is x over r, everybody. Cosine is x over r. So 2 square root of 2 over 3. X over r. Let's look at identity. Sine squared plus cosine squared equals 1. Sine is negative 1/3, so negative 1/3 squared. When you square it, you get 1 over 9. And subtract it from the other side. Cosine squared is 8 over 9. Cosine is plus minus square root of 8 over 9, or plus minus 2 square root of 2 over 3. Because we know the quadrant and cosine is positive, we choose the positive 2 square root of 2 over 3. All right, pretty straightforward. Let's look at the following. Tan of cosine inverse of negative 1/3. Again, we're going to call this theta. So cosine inverse represents an angle or arc. Therefore, we are looking for tan theta, which means cosine of theta is negative 1/3. We are looking at cosine inverse. Remember, cosine inverse is between 0 and pi, and it's negative. Okay, so it has to be the second quadrant. And in the second quadrant, we know tangent is negative. So we know the value of cosine. We want to find the value of tangent, and we know it's negative. So if we go with x, y, r, cosine is negative 1/3, which makes it x over r. Choose x to be negative 1, r to be 3. And that means you can calculate the y, because x squared plus y squared equals r squared, or 9 again. And y is 2 square root of 2. Again, I write down. Okay, let me just show you. X squared plus y squared is 9. Which means x squared, meaning -1. So -1 squared plus y squared is 9. So y squared is 8. And that's how we get this. Okay, everybody? And so if you look at this triangle and a bigger picture here, this is 1, everybody. This is 3. Okay. So this distance is 2 square root of 2. And we know tangent is y over x. Y over x. And that's 2 square root of 2 over -1, which makes it -2 square root of 2. Again, you can find a relationship between tangent and cosine, okay, and come up with the answer using tan squared plus 1 equals secant squared. You can try that, but I'm going to move on. So you can try because remember secant is what? Is 1 over cosine. So you can find easily the relationship between the two, and bear in mind that we've decided that the sign is negative here, okay? Let's look at secant function. Everybody remembers if I want to graph secant, I go with cosine and I flip it over. That's the best course of action. So we're going to stick with what we do with cosine, which means we restrict the cosine. Okay, so we restrict the secant in the same manner. So y equals secant is between negative to positive infinity. X can't be 2 and plus 1 times power 2. And absolute value of y is larger than 1. That means anything between -1 and 1 is excluded. So if we want to go with the inverse function, y equals secant inverse x is secant y. Absolute value of y now becomes absolute value of x is greater than or equal to 1, and y is between 0 and pi, and y can't be power 2. Because secant is 1 over cosine. Remember the restriction we put on cosine that it goes between 0 and pi. We're going to put the same restriction, and of course the reason y can't be power 2 because it's a vertical asymptote. So you do the restriction for this part, okay, this part, okay. We're going to go from 0 to pi, and now you can graph its inverse, which looks like that. And again, all you have to pick up a few points. Class 0, 1, for example, becomes 1, 0. Okay, pi -1 becomes -1 pi, and you can pick it. Just all you have to pick up a couple more points, and you know it. And the vertical asymptotes become the horizontal asymptotes. Okay, so we have symmetric with respect to y equals x. And the bottom line is those are the graphs if we separate them and isolate them, which makes it easy to see. So here's an example for find secant inverse of 2. Well, let's call it theta or x or y or z. By definition of an inverse means secant of theta must be 2. That's the meaning of it. And if secant is 2 and secant is 1 over cosine, then cosine must be 1/2. So theta must be pi over 3. It's a common arc. So obviously, we use the knowledge of cosine to get to the answer for this case. So again, pay attention. A quick recap. We restricted Okay, this part. Okay, which is this part. And then resulted in the inverse function like so. The vertical asymptotes result in horizontal asymptote y equals there is a vertical asymptote here, there is a horizontal. Let's look at inverse cosecant function. As you know, we graph sine and then we flip it over. And the restriction on sine is that for cosecant, of course, the domain x is from negative to positive infinity. X can't be in pi. And the range is all real numbers except between -1 and 1. And this represents that absolute value of y greater than or equal to 1. And so y equals cosecant inverse x. That means x is cosecant y. Now x is larger than or equal to y instead. And y is between negative power 2 and power 2, where y can't be 0. So we use the same restriction as we do for sine. And of course, y can't be 0 because that is the vertical asymptote. So if you were to graph, so we are looking at these two pieces only. And again, power 2 becomes 1, power 2, negative power 2 becomes -1, negative power 2. And it looks something like this with a vertical asymptote to be the y-axis here. Now the horizontal asymptote is the x-axis, which has the equation y equal to 0. As an example, a cosecant inverse of 2. So let's call it theta. By definition, cosecant theta is 2. We know that cosecant is 1 over sine, so sine must be 1/2. And sine equals 1/2 is a common arc. Theta equals pi over 6. That's how we come up with the answer.